Hi guys, hope all doing good. In this demo session we will utilize the acceleration analysis topic of theory of machines for deriving centripetal acceleration of circular motion. When we consider an object rotating in the circumference of a circle about the center O of radius r with uniform angular acceleration alpha, then let us consider initial position is at A and final position at A dash, and it reaches from A to A dash in infinitesimally small time delta t and has this angle with delta theta. Initial angular velocity be omega. We know that for a tangential velocity in a circular motion is given by angular velocity into its radius, and from kinematics part we know that final velocity equals to initial velocity plus acceleration into time. Now in circular motion, this v is an tangential velocity. This acceleration also we have to consider tangential acceleration. Okay. From that, if initial velocity tangential velocity is v and final tangential velocity at a dash is va dash, then va dash will become va plus tangential acceleration into time is we have considered delta t. Now va dash equals to, then this va is nothing but initial angular velocity omega into the radius r, which is equals to omega r, plus tangential acceleration is nothing but at equals to angular acceleration into radius alpha r into time delta t, which implies va dash equals to omega plus alpha delta t into r. Let this be equation number 1. Now for centripetal acceleration, as we require components along OA, we will consider all velocities along OA and we will find change of velocity and then acceleration, centripetal acceleration. So along OA, initial velocity along OA is 0. Initial velocity equals to 0 along OA, because only velocity component existing is VA, which is tangential, which is perpendicular. Now final velocity is along OA is VA dash sin delta theta. From this, change of velocity equals to final minus initial equals to VA dash sin delta theta. Now when we substitute VA dash from here to here, we will get the change in velocity is nothing but omega plus alpha into delta t into r into sin delta theta. So acceleration along OA, the centripetal acceleration, it is will be nothing but change of this velocity per unit time in which this traveling is taking place. So centripetal acceleration AC will be equals to omega plus alpha into delta t into r sin del theta divided by delta t. Now as delta t tends to 0, delta theta will also be very small and tends to 0. As delta theta tends to 0, we know that this sin delta theta will tend to delta theta. So finally we can substitute that, we can write it as omega r into del theta by delta t plus alpha into r into delta theta. Which will become delta theta by delta t is nothing but omega, angular velocity. So this will become r omega square. But second, when we consider this delta theta, we have earlier concluded that it tends to 0. So this whole thing tends to 0. So finally we will get is r omega square, which is nothing but angular centripetal acceleration. Hope the concept is clear.